So today we're going to begin lesson 4.3. We're going to talk about trig functions on the unit circle. We're going to just do part 1 in this video, and then we will continue with part 2 at a later time. So first, let's look at what we call a reference triangle. A reference triangle begins with a point in space. So we've got this point in space, this xy value that we are at. The first thing you want to do when they give you a point in space is you want to connect that with the origin, and you want to create our hypotenuse. So the hypotenuse is created by connecting our point and our origin. The next thing we want to do is create our x and y of our triangle. We create our x and y of our triangle. We create our x. Well, first, the easiest one is to create is our y value. We're going to always drop down to the x-axis. So we drop down to the x-axis, that's our y. And then we connect it over to the origin, and that's our x. So that's how we always draw our triangle. The angle theta is always the angle sitting inside of our triangle, and we many times are going to refer to that as our reference triangle. So our angle closest to the origin inside of our triangle, that acute angle, we will many times refer to that as our reference angle. Now let's just look for a minute how we found this hypotenuse. Well, we know that x and y comes from our coordinates. So our hypotenuse, if we solve that using our Pythagorean theorem, we find that our r is always just our square root of x squared plus y squared. So let's think about the things we know about our trig functions. You know that opposite theta in this particular case would be our y, and adjacent to theta would be our x, and the hypotenuse is our r. So let's fill in our 6 trig functions based upon the triangle lengths. So cosine would be adjacent over hypotenuse, so that's x over r. Now we know our secant is the flip of that. Our sine would be opposite over hypotenuse, so that would be y over r. So our cosecant is the flip of that, so that's r over y. And then finally our tangent is opposite over adjacent, or y over x, so our cotangent would be x over y. So if we know that point in space, we can fill out a lot of the information on our trig functions. And if we just take a second and calculate r using the Pythagorean theorem, then we can easily do every one of our trig functions based upon our SOHCAHTOA knowledge and our reciprocal knowledge from before. Now, because of the fact that our coordinate plane is broke up into quadrants, our triangles might land in any of the 4 quadrants. If they land in this first quadrant, our triangle looks like the one we see here in red, this one. If we land in the second quadrant, it's like the one in green here. If it's landing in the third quadrant, your triangle, or your reference triangle, would look like that. And then if you're landing in the fourth quadrant, your triangle would look like that. You'll notice every single time our point is connected to the origin, and our angle is the angle closest to the origin. So let's look at our first example. So it says that we have this point at -4, 3. So that would land us in the second quadrant. And then let's think what we need to do. We want to find the exact values of the six trig functions for theta. So where's theta going to be? Well, we're going to drop that down to our origin. That's always your first step. And then we're going to drop straight down, find your x-axis. We're going to label what our points are, so our x value goes here, and the negative tells us the direction, and our y value goes here. Our theta is always the acute angle closest to the origin. So now that we have everything set up, usually the next step you want to take is to find your radius. Our radius is going to be the square root of x squared plus y squared, just our hypotenuse using the Pythagorean theorem. So that's going to be 9 plus 16, or the square root of 25. Now your radius is always positive. It's just a distance. Your x and y values can take on a negative depending on where they go. So now we know that our hypotenuse is 5. So let's find the 6 trig functions related to theta. So we've got, just do your good old SOHCAHTOA. So sine of theta, cosine of theta, tangent of theta. And then let's do our reciprocals, cosecant of theta, secant of theta, and cotangent of theta. So our sine of theta is going to be opposite over hypotenuse, so that's 3/5. Cosine is going to be adjacent over hypotenuse, so you'll notice it's negative. That just tells us that it's going in the negative direction. And then tangent is going to be opposite over adjacent. If those needed to be reduced, of course we would reduce them. Now our cosecant, our secant, and our cotangent are just the reciprocals of the original 3, so now just flip them over. So that's 5/3, negative 5/4, and negative 4/3. So those are the 6 trig functions in relation to where that point is if it was on a terminal side of an angle. And that's the way that we would find those. Now let's go ahead and try another example. So it says to find -3, -6 if it's a point on the terminal side of an angle theta in standard position. So standard position puts us the acute angle closest to the x-axis. So once we draw where the point is located in space, then we need to draw in the triangle. The triangle is going to help us find our 6 trig functions. First thing you always do is connect that point to your origin. Then you're going to drop to the x-axis, whether it's above you or below you. If you're under it, drop up or go up. If you're above it, drop down. And then we're going to label our triangle. We went 3 to the left and 6 down to get to that point, and our theta is always closest to the origin. So this is our opposite. This is our adjacent. And we will find our hypotenuse by doing the Pythagorean theorem. So let's do that. So our hypotenuse we label as r. Our hypotenuse is going to be the square root of 6 squared plus -3 squared. Or it's going to be the square root of 45. Now when you get a number like that, please just go ahead and reduce it down as much as possible. We know that's 9 times 5, so when we square root that, that would be 3 radical 5. And that's what I want. And when it says exact values, that tells you what you want to do. So I want to leave my hypotenuse as 3 radical 5. And then let's write down our 6 trig function. So we know our sine is opposite over hypotenuse. Our opposite is -6. Our hypotenuse is 3 radical 5. Now normally we don't leave it like that. 3 goes into -6 -2 times. We should rationalize it. So if we see -2 over radical 5, that's the same as -2 radical 5 over 5. So I might not have enough room here, but we'll try to put that right there. Now our cosine is our adjacent over our hypotenuse, so that's -3 over 3 radical 5. And if we reduce that down, That's just going to be negative radical 5 over 5. Our tangent is opposite over adjacent, so that's negative 6 over negative 3, or 2. So for our cotangent, if we flip over 2, that's the same as 1/2. For our secant, if we flip over that, we get negative radical 5. And for our cosecant, if we flip that over, we get negative radical 5 over 2. So that's how you would do it. Just be careful with your signs if you're dealing with the signs of things. And remember, if a radical goes in the bottom, we're going to flip it to the top and leave its normal version behind. Let's do our last example. Now let's analyze something for a minute. Our sine is, we learned earlier that if we really look, it's y over r. Y is the only thing that gives us a sign on it, that being positive or negative. We know tangent, if we look at the tangent being opposite over adjacent, that's y over x, okay? So when we look at the fact that the sine is less than 0, what that tells me is that my y is negative. Now, if we look on the xy coordinate plane, if you think about that, the y's are negative here and here. Now let's look at our next piece. It says our tangent is positive. Now remember, both y and x can have positives or negatives on it. So tangent, it will be positive in this quadrant because they're both positive, or in this quadrant because the x and y's are negative. So the only place where my sine will be negative and my tangent will be positive is in this quadrant. So that tells me where to put my triangle. Kind of weird to think about, but you got to think about a mixture of things when you're doing problems like that. Now, it says to find the exact values of the other trig functions. Now let's look what we know. We know the tangent is 5 over 12, which we can normally, and now that we have our triangle set up, we can still think of it as opposite over adjacent. And we can plop those numbers in. But we also even more specifically know that that is our y. This tells us that our opposite is y and our adjacent is x. So let's put those on. Our opposite is the y direction. Our adjacent is the x direction. So, but look, we're in that quadrant. This point here is negative 12, negative 5. So we got to remember to put the negatives on. Now also, now it's time to do the Pythagorean theorem. So r is going to be the square root of 144 plus 25. Or r is the square root of 169 or 13. Now remember, your r does not have any positive or negatives to it. It's just a positive value every single time. So let's think about what we know. We have our sine, our cosine, and our tangent. Now we already got that one, so let's just write that one down. And then we need to find our cosecant, our secant, and our cotangent. So the easiest one to find, we don't even have to look at our triangle anymore, is our cotangent. We know our tangent's 5/12, so we know that our cotangent is 12 over 5. Now let's set up our other ones. So sine is y over r, or you can also think about it as opposite over hypotenuse still. Same old rules apply. So that's negative 5 over 13. And then our cosine is adjacent over hypotenuse, or x over r, so that would be negative 12 over 13. And once we know those, flip them over, you got the other ones. So that would be negative 13 over 5. It's customary to always put the negative in the top, so I always tend to do that. And then negative 13 over 12. So that is how we find them when we're given these kind of interesting clues. We base it on what we know about our quadrants. So the assignment that goes with part 1 is everything you see here highlighted in yellow. So that's where we're going to start. And then we will continue with the part 2 section. And we'll do that another time.